Hi. In the last video, I showed you how to go to the GitHub site and create a fractal design of your own making. The point of this video is to show you how to take the coding that you see in the GitHub site and apply it in our special Geogebra file that we created for you. So, in the GitHub site, I modeled how to create a fractal. I actually ended up making the Sierpinski triangle, which is a famous and pretty simple fractal to generate. The Sierpinski triangle is made from 3 matrix lenses. All 3 of them have been dilated by 50%, and they have been rotated 0 degrees. There's no rotation applied to any of these matrices. And then you just have to move them to where you need them to be. The first lens stays centered at the origin, the second lens moves over half of a unit, and the third lens moves over a quarter of a unit and up a half unit. So once you've worked out what the dilation, rotation, and translation components are for your specific fractal, then you're ready for the Geogebra file. So here we come over to the Geogebra file. In this Geogebra file, there's a menu that you can scroll through with a whole bunch of information. It's in this menu where you're going to have to encode your own specific matrix. So, I have 3 lenses. What I'm going to come down here, scroll down a little bit until I see the category called number. The D1, D2, and D3 values are the 3 different dilations of your matrix lenses. R1, R2, and R3 are the rotation values of your specific matrix. So for the Sierpinski triangle, it turns out the dilation factor was 0.5 for each one of them. So I'm going to go in here and change this to 0.5. I'm going to make the dilation 0.5 for all 3 lenses, in fact. The rotation, your fractal will probably have some rotations in it. The Sierpinski triangle has no rotation, so I'm going to leave those set at 0 degrees, 0 degrees, and 0 degrees. When I scroll down a little bit, at the very bottom of this input menu, that's where you see the translation vectors for your first lens, second lens, and third lens. For the Sierpinski triangle, the first lens is translated nowhere. It has no horizontal or vertical translation components applied. For the second lens, I need to move the x-coordinate. I need to move the lens a half a unit in the x direction, but nothing in the y direction. And the third lens, I need to move a quarter of a unit in the x direction and half a unit in the y direction. So once you have encoded your lenses, what we're going to do is scroll all the way back up to the top. And these L buttons over here show you the different levels of the fractal that this program can generate. So the first one is going to be pretty boring because that's identical to the original XY unit square that you're seeing on the screen right now. But things get a little bit more interesting when I click on the second level. When I toggle the second level on and off, you can see that 3 copies of your lenses have now appeared on the screen. So it's a little hard to see because they overlap with the X and the Y axes, but you might be able to see there is one lens in the bottom left-hand corner, there's a second lens in the bottom right-hand corner, and a third lens has been positioned halfway across and half of the unit up. So that's actually stage 2 of our fractal. And with this idea of the multiple reduction copy machine, I can replace each one of those lenses with copies of itself, and we get stage 3. I can then turn off stage 3 and replace it with stage 4. And as you can see, hopefully, as you get deeper and deeper and deeper into the fractal, we only coded our program this GeoGebra program so that it would go 5 levels deep, but I'm hoping that you can see that the resulting image, after 5 iterations of the matrix coding, this image is starting to look very similar to the Sierpinski triangle that's listed at the GitHub site. For this project, all you need to do is take screenshots at the appropriate levels. So take a screenshot at levels 3, 4, and 5. Paste that into your shared document. Thanks for watching.